Okay, so hello everyone. I guess I see some questions in the chat. Most of them may be with regard to the lab. So when I checked the GitHub repository, I found most of you already was successful getting things in, so that's perfect. But for those who already still have some issues, please feel free to drop in the office hours and either today, tomorrow, or even on Friday. I will do my best to also be there with the TAs to help you. So we are putting more support in the remaining 2-3 days until the submission to make sure you guys are getting the environment set up correctly before the deadline. Good. Okay, so let me see if there are other questions that are not related to the lab. Okay, another thing. Many of you asked about the midterm. I have already posted an announcement on Avenue with the midterm date. More details will come in on how the midterm will be conducted, what is the format of the exam. We are still kind of experimenting with few things to make sure it's the easiest experience and the most productive one for you. So soon I will let you know as well during one of the coming lectures. Good. Let me see if there are any other logistics that I have in mind. Yesterday's lecture will be uploaded today. It's already, in fact, uploading and processing right now. So it will be ready. The other thing, also, I posted Lab 1, but you shouldn't worry about Lab 1. It starts next Monday. But for those who are done and want to experiment, the Lab 1 is already there on Avenue. Do you have to write the lab? Yes, you have. You basically have to follow all the instructions. There are no specific assigned lines in functions. It's just a space where you can write your code. So I give you some hints, things to do. So you have to follow all the instructions there. Is there any way to help with Lab 0? Yes, as I was saying, we have already office hours going on every day from 10:30 to 2:30. I make sure, especially for these first 2 weeks, to drop in office hours and lab sessions as well. So most probably you will find me when I have time with the TAs. So don't worry. Hopefully by the end of this week, everything with regard to the environment will be fine, and we will give you the full support until you get this in. Once you have the environment or Lab 0 done, coming labs will be exactly the same thing. So you don't need to go through this setup experience anymore. Maybe with few steps needed for Java, but the main environment, the GitHub setup, all these things will be exactly the same for all the labs. So once you have this initial effort you have put in Lab 0, all the remaining labs will be focusing on coding using exactly the same environment for testing and submission. Okay, so let me start with today's lecture, because today's topic is in fact very important and it might take us some time. So functions, right? It might seem that we waited until this 4th or 5th lecture until we discuss functions, but that's in fact not true. From the very first lecture we started coding in C, or even in Lab 0, you guys have dealt with functions whether you were aware or not. For example, we used scanf and printf, which back then I told you we are calling a function that is implemented already in the C standard library, and this is the reason why we needed to import the header file story.h, right? So what we would be doing then is we were using a function that was already implemented. Today's lecture will expand more on that. So we'll see how to implement a function ourselves. Even in fact, in Lab 0, the add function is a function, right? And you wrote the code for it, and the test environment was calling this function. So when you added the third test case, what you have done is you called add function with certain inputs, right? So you are somehow dealt with writing a body of a function, which is defining a function, and also calling a function from another function, either the scanf, printf from the main, or the add function from the test environment. Good. But now we will see in more details what are all the fundamentals of defining functions, prototyping them. So we will touch this topic in more detail. Good. Okay, so why do we need functions? So functions are kind of modules in a program. So the thing is, you need to differentiate between functionality, which means what the program is doing, and writing the code in an effective way. For example, I can write exactly the same program without using any functions except the main, because we said use of the main is mandatory in C, right? So all your code is in a single function. But this is not going, first of all, to be very readable, even for you, not very easy to debug. And the third thing is not modular enough, right? So you cannot reuse your code in somewhere else. But if you take every single entity that represent a module on its own and define it as a function, then you make your code more readable, and also it's more usable, such that if in this program you implemented an add function, in another program you can re-import the add function and use it. You don't need to rewrite the code for the add. Adding is just a single line, but think of an algorithm that takes thousands of lines. You don't need to rewrite this for every project you do, right? Once you have this code, you can just use it. And think of the usability we had by using the scanf. We didn't need to write the scanf code, which you can imagine is maybe tens of lines of code or hundreds of lines of code. We just used it directly. Why we were able to do this? Thanks to functions in C, right? So functions provide us with software usability, such that you can reduce the development time for future projects. And I give you the example of using some of the standard library functions. And also, you allow your code to be used by other programmers, right? For example, you did a project, you are working 10 in a team, or even you do it alone, but others are asking you to say, oh, you implemented this algorithm in an efficient way. Can we use your function? So you just give them the prototype of the function, the header file, the implementation, can they easily use it, as we will see right now, right? The second thing is modularity, as I mentioned. Even you don't want someone else to use your code, or you don't intend to reuse this function in the future, it's still helpful to have functions in your program because it improves readability, right? Think of just sequential 1,000 lines of codes in a single function, how you can reason about this, how you can explain it from one side. And think of the other case, which is you modularize your code in a good readable way. Every entity or every single step in your algorithm is implemented as a function, so it with a meaningful name, so it's much easier to read, right? So in fact, functions is kind of the very first step towards object-oriented programming, which is a completely different concept, like classes, objects, having encapsulation of your code such that others can use it, and you can have modularity in your code. Functions are not all of that, but they are the first step because they allow you to enclose a certain operation within a function. And then you deal with this full operation as a single entity. You don't need to care about the details of the implementation. You just pass input to the function, look into the output. Again, think of the printf. We just needed a single line of the printf, passing a message to print. How is this implemented? We didn't even care, right? And this is thanks to functions. The same thing for scanf. We knew that we need to take the input from the user, place it in a certain variable, and this is all what we needed to care about, how to use the function, right? Good. So there are three main things about functions that we need to know about. As I told you, you already kind of interacted with some of these. The first one is the actual implementation of the function, what we call a function body or a function definition. The second one is the function prototype, and we will see what does it mean now. And then the third one is function calling. So you need to use the function in somewhere else. Again, printf that we used in the main was function calling because you were calling another function. Scanf, the same thing. Calling the add function in your test case was also a function calling, right? So you implement a function, you prototype it. We'll see what we mean by prototyping for now. And you use the function, which is the call, right? Okay. So let's take a very easy example. Assume I have a function that I call my mean square. And this function is implemented somewhere. It takes only 2 inputs and it gives me the mean square of these 2 inputs as an output, right? So the way you call the function, similar to what we have done before for printf, scanf, or add function, what you do here is you just write the function name, pass the input parameters. We call these input parameters. And then here, you take the return or the output of the function into a variable. These are the steps that you call a function to execute a certain task. How is the mean square implemented? You didn't care, right? So this is the function calling. So now let's look into the implementation itself, right? Or what we call a function definition. Assume that you are the one that is implementing the function. So first of all, this is the function header, which also later we will call as a prototype. You decide what are the types you read as an input. So you read 2 double inputs, X and Y, and then you return a double as well. So this is the return of the function. And this is the actual body of the function, which is the implementation. You simply just say, I define a third variable. I just take the square of every input and then divide by the number of inputs, which is here 2. This gives you the mean square. And then you return Z, which holds the result, right? Compare this with the add function we had. We also read 2 int as input 1 and input 2. We did the sum in a variable, third one, which you can call sum, equal the summation of these, and then you return sum. Exactly the same process, right? And then finally, the third step, which may be the one that you didn't pay attention to until now, is what we call a function prototype. Here, we have the implementation of the function after the main, right? So it's if you have this as a single file, we define the my mean square after the main. The problem, if I try to call my mean square here, we said before that the compiler starts from the main, which is the first line here, right? I start the execution from here, and I move line by line. Once the compiler reaches to this line and say, oh, there is my mean square function, but this is not defined anywhere because the definition comes later after the main, right? But the compiler is sequential, so it will complain, right? Because my mean square is not defined yet, and we said you cannot use anything in C without definition. Here comes the rule of a prototype. Simply, if you write the implementation of your function after the main, or it appears after, you add a single line before the main, which is basically the header of the function itself, the return type, the name of the function, and the inputs it takes. And then you end with a semicolon. We call this function prototype because it's the interface between the function and the outside world, right? As someone who needs to call a function, this is all the information you need. By adding this line here, you tell the compiler there is a function that its implementation will come later, but when you encounter it in the calling, don't complain, because now the compiler will know what is my mean square, right? So again, the 3 things we have in any function: the prototype, which is this line here, the actual implementation, which is the function body itself, and the third one is when you call a function to use it, right? We said that the purpose of the function prototype is if it appears as an implementation after the main. What if I moved the body before the main? So I moved all of this, which is the function definition, before the main. In this case, you don't need a prototype, right? Because I mean, the compiler will see the actual implementation of the my mean square before the main. Good. Okay, let me see if there are questions. I just want to say, in fact, you guys reply to each other, which I'm really happy with this spirit of helping each other. But the problem is it kind of confuses me between, like, it doesn't give me a very handy way of looking into questions, right? So what I suggest is maybe you delay the reply a little bit, because I will try to reply as much as I can. But if I see replies, I need to read all of that, which doesn't work in a couple of minutes, right? Okay, let me see. There are given, thanks guys. Okay, no like a function in a program like int, my function, my variable. as you can see, it's very hard to capture a question. We don't need scanf in this type of coding. Okay. Yeah, so let's see later if there are kind of other questions that I can look at, because right now I'm not spotting any question I can respond to. Okay, let's move forward. So we had an example, and this example kind of give us the main rule, but let's look into the template itself, like the general rule, right? As we said, in front of the function, you put the return value type. In lab 0, it was int because we were returning the sum of two integer variables. In the previous example, it was double because I was returning my mean square. In general, it can be any type, right? One question here, what if my function is not returning anything? Remember, printf didn't return anything. Printf was just printing a message, right? So then you just write void, right? Void here means you return nothing. So you're not expecting a return statement. Good. And then function name, you can choose any legal name you wish. For sure, you cannot choose a function name that already exists in C library. You cannot call a function scanf, for example, right? And it has to be legal name. You cannot start with, for example, a special character or a number or these kind of things. And then you have the input parameter list here, which is in previous example, it was X and Y. In the lab, it was input 1 and input 2. And then again, the body, which is you define some declarations, you do the actual implementation of the function, and finally, maybe if you need to return something, you end up with a return statement, right? This is the general template of having a function definition. So one important thing in C, and in fact, it's a kind of a limitation that sometimes you need to get across if you do advanced programming in C, is you can only return a single type from a function. You cannot return 2 variables or 3 variables or 4 variables, right? You cannot say, for example, I want to return X and Y and Z, so I'm returning 3 doubles. This does not happen in functions in C. What you can do instead is you can place all of this. We can do 2 things. The first one is I can return a data structure, because a data structure is a single type. I can return an array, for example. The other thing is you can pass values you want to change as input parameter to the function itself. Can someone remember an example we have done this? We have done this in scanf, right? We passed an input that in fact scanf was modifying. This is as if you are returning a value from the scanf, right? But you don't take it as return. In fact, you take it from the input of the scanf, right? So we pass the variable, what we call by reference. You allow the function to modify it, and this allows you to capture a return from the function without need for the return, right? So if you want a function to return 100 things, you can pass all the 100 things as input parameters, but by reference, such that the function can modify, right? Okay, we already mentioned the function prototype. It's just the first line of the function, which has the return, the name, and the input parameters. So one use you will see in the function prototype, and this is in modular programming, and this is what we have in our labs, is we have a header file and a source file, right? And some of you were confused, what is that? So for the header file, I said before, you usually have all the definitions. A function prototype is a definition. So usually people in good projects, they place all the function prototypes here. And then in the source file, they include the header file that they define to include the prototypes, and then implement the actual body here. So you would have the prototype in a header file while you have the actual implementation in a source file, right? This is a kind of a modular implementation of any project. Why this might be useful? Because as someone that maybe I'm a user and you want to hand to me or you want to deliver your project to me, what I need to care about is in fact not what you implemented, not the details. How did you write your mini square function or the add function or any other detailed algorithm? What I care about is how to use your implementation, which I only need the prototype for. So header files work as an interface between you. It hides all the details from the previous from the end user, and it allows him to easily use your code without caring about the implementation. For example, again, we have already used this as users. We included the story.h as input in our program, and we use the scanf printf without caring at all where is the actual source file of the scanf printf. Good. Okay. So one thing you have to care about is that the prototype has to be exactly the same as the function definition first line. You cannot, for example, define a prototype that takes int x, int y, and then in the implementation you say, no, I decide to take 3 input parameters, int x, int y, int z. The number of parameters has to match, but also the types of parameters have to match, and their order as well has to match, right? So it has to be exactly the same between the prototype and the first line in the implementation. Okay, so function calling, which is the thing that we are we use the most, is you call the function from another place to use, right? You pass the input parameters that the function needs to do the actual implementation, to the actual processing. The function does the processing for you, and it returns something from you for you that you take in a third variable, right? So in the example we had, we called my mean square in the main, pass 2 input values, a and b. The function, so at this point in the code, so we said the compiler starts executing from the main, correct? Like the first line in the main. You move line by line. Once you reach the point that you are calling another function, the compiler will switch the context into the function implementation. So it will move from the main. So here, this is the main. Assume this is the main in the stack, the main stack in the memory, right? And at a certain line here, you called my mean square. And then my mean square is in another place in memory, right? The compiler is moving line by line, line by line, line by line sequentially until it reaches this function call. Then it changes context to jump into the actual execution of my mean square, taking these 2 inputs, as we will see right now, do the processing, return the value to you. Once you reach the return, it will go back to exactly the line after. Okay. The line after the function call, right? So it knows exactly where it stopped because it stores this somewhere. And you will see this in your digital design and like embedded systems course, because you need to take care of this context switch yourself. But for now, what you need to understand is I hit a function call like my mean square in main. I leave the main completely as a compiler. I go to execute my mean square lines one by one until I hit the return, take the value of the return, place it in the variable C in the main, and continue executing the main, right? So by default, the compiler is a sequential execution until it reaches what we call a jump. It changes context to the function that is being called, and then, or the callee function, and then it executes it and returns to the caller directly on the same line. Good. So let's see what happens in reality. So assume, maybe I need to change the place of this. Okay, good. So let's see what happens as at the memory storage, what happens by the compiler. So here we have the same example, like I have my main square implementation and calling the main. I define 2 variables as double, a and b, 10 and 20, and then pass these as inputs to my mean square, which means a will be mapped to x and b will be mapped to y, right? And then I start executing. Once I hit here, the compiler will jump, as I said, by executing the actual implementation of my mean square. I define a variable called z, and then so if we just move forward, once I start executing the function itself, I have 3 variables, x and y, and then I also define z. These are local variables for my mean square, and we will see now what we mean by local variables, but they are within the context of my mean square, within its stack. And then I pass a and b to it. So X will get the 10 from A, and Y will get the 20 from B. And then you do all your squares. So you change X to be X squared. So now X will be 100. And then you change Y to be Y squared. So it will be 400. And then you will calculate Z as X plus Y divided by 2. So it's 250. And then now you return Z. By returning Z, where I'm taking my return value from my mini square, it's in the C variable, right? So C will be equal once I return, C will be equal to, come on. C will be equal to the 250. And once I return from my mini square, because these were local variables that are only within the stack of my mini square, once I am returning from my mini square, all the memory places for the X, Y, Z will be destroyed. They are not used, right? But one very important thing for here, for you here to understand, A and B were mapped to X and Y. So X took the value 10, Y took the value 20, and then we changed this to be X squared. We changed this to be Y squared. But once we return it, A and B didn't change, right? So input parameters to a function, because these are separate places in memory, they are distinct memory entries, all the change will be in this X and Y. It will not reflect in A and B, right? So A and B would remain exactly the same. And this is very important. This is called pass by value, which means you only pass the value of the input parameters to your function. Whatever change you make internally, it does not reflect in the input parameters. The only reflect you will get from the function is the return value. And we have seen that Z is passed to C, right? What if I want really to change A and B in the main? Remember what we have done in scanf, right? We passed their address, and we will see now what we mean by this, what we mean by pass by reference. But for now, by default, all the variables that you pass to a function, they are passed by default as by value. So that means input parameters does not change. For example, if here you try to print A and B, they would remain 10 here, like in this line, they would remain 10 and 20, right? They will not be 100 and 400. Good? Okay. This is we already explained. Okay. Here, we kind of have another example, is that assume I'm implementing a function called max, where I'm returning the max of two input variables, X and Y, right? And to give you an understanding of this pass by value and pass by reference, we will see before we call the function max, what would be the value of the A and B in the main, and what would be the value afterwards. So as a compiler, think of as a compiler, I'm starting from the main, this line. I see that I define two variables, A and B, as float. I do a scanf to read them from the user. So I read A and B. And then I print the value of A and B, just whatever I read from the user. So if it's 10 and 20, then assume here the user inputted 10 and 20. So this printf will show you that A is equal 10, B is equal 20, right? Then in the last line before the return, I'm printing the max and the actual return of the max. Remember, max is returning an int, right? So once here I'm calling the function max, the compiler will go to its execution, does all the operation, and then finally give me a single value, which here I'm reading, right? Good. So max I pass 10 and 20. 10 will be for X, 20 will be for Y. And then here I'm printing, so you would expect that X would be 10 and Y will be 20. And then you return. If x is larger than y, you return x, otherwise you return y. This is what this line means, right? It's like an if condition, but condensed. It's called conditional statement. So what you check is, this is a condition. So you say, is x larger than y? And then you have this question mark, which is kind of telling you that this is a condition. If yes, execute the first line or the first statement. If no, execute the one after the 2 colons, right? So here, x is not larger than y, so it's false, so it returns y. So the return of the function is 20, which means if you go here, what you will see at the end, max equal 20. Good? Is that clear? Here, one thing that this example is trying to show you. X and y are integers, right? But a and b are floats. Despite that, we passed a and b to x and y, and things should work correctly. This is what we call auto casting, right? What we mean by this is simply the compiler, but in some compilers, as we have seen in the online GDB, because it's limited compiler, it might not do that for you. But some compilers will understand that, oh, this is an int, so I'm going to round the value into the nearest integer and then pass this to the function myself. Others will say, oh, warning, you are trying to cast an int to a float. Others will say, oh, that's a problem. It's like the online GDB, right? So you are not recommended usually to do this, but I'm giving you the example to understand that the compiler can do some work for you, like the casting by default, right? We'll discuss casting. Casting in general means transforming from one type to another type. That is possible, right? For example, float can be transformed into double. The other way around is correct because both are decimal floating points. Float and double can be transformed into int by rounding. Int can be transformed into float and double because you can represent any integer value as a float value. 1 is 1.0, right? But casting is generally transforming across types. Good? So let me see if you have other questions here. That's an excellent question. Okay, so what if I pass 20.3 and 20.9? X and Y will be 20 and 20, right? Then let's look into the condition, this condition that we are deciding based on. Is 20 larger than 20? No, right? So the condition is false, which means you return the second one, which is still 20. So you will be returning 20, which is also correct, right? Good. But the problem, as you can see, it doesn't work exactly as you intend, because by casting from float to int, you are losing the precision, right? Because 20.3 and 20.5 would be the same thing for you, right? Yes, for the one that was asking, does it round down? Yes, usually the casting will only round down. It truncates it, correct? So it doesn't round. I mean, truncation is one type of round, right? We have, in fact, in architecture, like in the laptops, there are 5 types of round. One of them is truncation. So it rounds down. It's called round down. So my terminology was still correct, right? But I see that most people see rounding as the only most common type, which is round to the nearest. But this is only one type of rounding. But truncation is, in fact, another type. So yes, it truncates. Good. But as you can see, this is not completely correct because you lose precision. Okay. Yeah, as written here, invoking function max with floating point arguments is not a syntax error because the compiler can do the casting for you, but it leads to incorrect results because of the example that you all kind of captured, right? Okay, good. So for sure, and maybe one step before that, to fix this, what you need to do, right? You need simply to just define your max with floats rather than ints, right? So you need to match the type. It tells you that you want really to match the type of your function. Okay, the other thing that is related to 2 things that remains in this lecture related to function. The first one is multiple source files. And again, this is you have already seen in your lab 0. And we kind of also cover this in the tutorial to explain how our unit testing work, right? So to have a scalable project, by defining functions, you allow yourself to split your code across multiple meaningful files. And instead of having everything, assume you have a project that has like 10,000 of lines of code. Having this in a single file, it's not scalable, it's not very easily readable, and for sure, this 10,000 lines can be factorized, like can be split into meaningful functions. So by defining functions, you can split your code across files, right? For example, if you look into Lab 0, we have our test environment completely in other files than our actual source code. So we had the add function, the questions. Generally, you will find the lab as questions.h, questions.c. This is our two files for the problems you solve or the question or functions you write. And we also have the test cases.c, test cases.h, all tests.h and .c. These are our test environment. So by having multiple source files and header files, you scale your project, right? So you make it as distinct. You have here source file, file1.c. For example, it has all your implementation of the math functions. File1, file2.c might have all your implementations of something like, I don't know, geometry, algorithms, something like this. And then here you have your main, which reads from here and from here, something like that, right? And everyone can has its own associated header files. Good. So let me see if there are questions before I jump into that in detail. Okay, again, you guys are answering questions. Thanks for that. But again, it makes it harder for me to see the questions, right? So maybe a terminology we can use if you want to keep answering things. Before your message, you can add in brackets either answer or question, right? And then I only look into the questions, right? This might be our kind of handshaking together to enable me to quickly spot the questions.
I have a question.
Yeah, go ahead.
Is it good form to put the main up top, or is it better to have the prototypes before the main and then the implementation after?
Yeah. So if you mean by having the main at top, but you have all your functions implementations afterwards, the compiler will complain because you have to have the prototypes before the main. But one thing that may be the best across all of that is to have your prototypes in a header file, right? And then include the header file at the beginning of your main file. And that's it. Then your main will be in the top, right? So
Okay.
you would have, for example, in our example that we had in my mean square, you would have another file, call it my mean square.c, for example, and my mean square.h, where you have the prototype in the .h file. And then you include this in your main, like you say, include my main square.h, and then now you will start your main directly. The compiler will recognize that once you call my main square, it already got the knowledge that there is a function prototype because you included the header file, right?
Okay,
This would be the best way of doing that. You're welcome. So you would question, good. Do we put the include lines in the header or the main file? That's also a good question if you work with multiple files, Arjun. So it's better to have all your includes if you have a file. So for example, I have a math.h, my math.h, my math.c. And my math.c, which implements your functions, is using some other header files from the C library. If your source file, .c file, needs some includes, add all of this in the header file, not the C file. So by default, but not all the C files will have an associated header file. But I'm assuming from your question is that you are saying for each C file, you might have a header file. Should I include the includes in the header or in the source? Include this in the header, right? Such that your source will only include the implementations. Thanks. We'll be making our own header and source files. You can if you want, for sure. If you mean for labs, you are already given the header files because we already include all the prototypes of the function definition. Some prototypes of the functions you will be asked to write, but you will be given the header file in the starter code. So you wouldn't need to do this in labs, but you can generally if you wish while you are exercising, for example, right? Why do we need to define functions before the main? Good, because a general rule in C You can never use anything before defining it, even functions, right? And prototype works as the definition for you. So this is why it has to be before the main if you are using it in the main. What is a header file? Is it still a source? Yes, but it's a convention that header includes only, again, definitions and prototypes. It doesn't include actual implementation. The actual implementation is what we call in a source file. But yes, it's still a C file because you write code there. But this code can either be the actual implementation, which we call the source, or just defining variables and prototyping functions, which we call a header. So it's a convention, right? What else can we add to the header files other than function definitions? All variable definitions as well, like int x, int y, if you want them to be global, right? And we will see now what we mean by global variables. Good. So to call function B from function A, we already did that. Yeah, so here you will get an example of, assume for example, you want to implement your own, as I said, math library, right? So something you can have, and this is an example that I advise you to kind of try offline after the lecture to make sure you understood the concept, right? Assume, for example, I want to write my own implementation of some of the math functions like add, sub, multiply, right? So now you can call this your math library, right? And you are going to call it my_math. Why we do this? Because math itself, math.h, is already in the C standard library. So you cannot call a file math.h. So we call it my math, right? Good. So to be modular, as we mentioned, we are going to use both header files and source files. In the source files, you do the actual implementation, as we mentioned, right? In the header files, on the other hand, you do the prototype, right? So here is the prototype, and here is the function body itself. Good. Now, assume I want to use these functions in my main. Good. And I guess, Nicole, also this kind of addresses your question, right? So what I just simply can do by including my math.h, I have already included all these prototypes, right? Which allows me to, for example, call my math sub or my math add without a compiler complaining about that, right? This makes sense? Good. Okay.
You don't have to put include my math.c
at all. No. Yeah. Okay. You don't need to include any source files. Think of what we have done in previous lectures. We used scanf, printf by only including studio.h. We never included a studio.c. And in fact, it's completely not recommended to include any source files in other source files. We only include header files. Okay? And the compiler will figure out the source implementation on its own. As far as the source and the header are in the same folder, you don't have an issue. The compiler will do that for you. Good. Okay, thank you. So as we said, we have been using functions ourselves multiple times, and the C standard library is one example of this. I assume, for example, we have used studio.h, but assume I want to use math.h, which have some of the most common functions for math library, like power function, square root, and other things. There is also the string.h, which has some string processing, and we have dedicated lectures for this. And the one that we are familiar with, which is studio.h. All these are header files we have been using, right? Other utility things like standard library.h, which includes some kind of convergence, dynamic memory allocation. We have also separate functions for that. Okay, the character type.h is also here. We are just giving you some examples of the header files in the C standard library that we might be using, right, in labs and in your actual programming. Good. Okay, so for example, if we have a look into the math library functions in the math.h, you have the square root, which just you pass one single input to it and gives you the square root of a function. Exponential, log function, log10. Absolute value, which is f_abs, power, sine, cosine, tan, ceiling, flooring, all of these are already existing libraries that you don't need to implement yourself. Unless I asked you, you are not allowed to use the math library, right? Because one thing to pay attention to in some labs, or even some questions in the exam, I would say implement this function without using the math.h, because I want you to to see how the algorithm is actually done. But otherwise, you are free to use whatever you feel you can use if you are not asked not to use, right? Okay, so the second most important thing, so let me check the time before looking into questions. So, okay, good. So I will cover this topic, and I hope at the end I will have some few minutes for the questions, because this is a very important topic related to functions, local variables versus global variables. So in our previous example, like my square root or my square mean function or my mean square function, we had two separate functions, right? And I told you that each one has its own memory space in the stack, right? So for example, x and y and z inside my mean square, this, I told you that these are only local variables for this function. For example, if you say in the main x equals z plus y, it will complain that x and y are not defined. Why? Because their scope is only within the function you define them in, right? And this is what we call by a variable scope in C. So let's have some examples to understand what I mean. If you define something before the main, it's usually a global variable. Global means it has a global scope in all the functions in your source file, right? So for example, here I'm defining float by equal 3.14. You can use by anywhere, right? Inside the main, inside functions, because this is a global variable, right? But on the other hand, if I'm defining int m equals 0 inside the main, if I have another function here, for example, my mean square function, I cannot say, for example, m equal 2. Why? Because m is only defined within these brackets of the main, right? This one and the last one. So m is called to be local to the main. It's only defined within the main, right? So generally, function parameters and variables inside the function parameters are the input to the function. And any variable you define inside the function are by default local to this function, right? You cannot use them outside the function. But functions that are defined outside any function, they are called global variables, and you can use them everywhere, right? So one question is why I don't define everything as global, I just like have a peace of mind, right? That's in fact a terrible idea, something that you shouldn't be doing for two reasons. The first one is global variables, because they exist for the whole period of the program, because they are global, they take more memory, right? So if you have a large project, the more global variables you define, the more memory you are using, so you might end up having crashing your memory, right? This is the first one. The second one is usability. You know that, for example, there is a variable that you only need within a function. Like for example, even not just a function, like within a block of code, you do an iteration through a for loop, right? So your iteration index is only needed within the for, right? You don't need it outside. And it might, outside, it might have a different meaning, right? So if you define all of this to be global, you get confused, because you would have hundreds of variables that you don't know which one is doing what, right? It's better to keep the scope as restricted as possible, or as minimal as possible, to increase readability and also save memory space, right? So yeah, as I said, global variables generally are not recommended for the reasons that I gave. Good. And maybe as a general rule, unless you are asked to do so, don't use any global variables in labs or in exam, right? Good. So let's have another example of explaining global and local variables. This is a very important concept. So here you find in this is a function prototype that is defining a function called square. And this is a global or a local variable. This is a global one, right? Because it's defined outside any function before the main. So it's a global variable. Good. Now, what about A? Is defined within the main, so it's a local to the main. And then if I go inside the square, here, what is void? That means I'm not reading anything, right? As an input. But inside the square, I'm using alpha, right? How I'm able to use this without reading alpha from anywhere, because alpha is already global, right? So you can just simply call it from anywhere, right? Another example, if I define alpha as only local to the main, if I try to do exactly the same thing, you would have a compiler error. Why? Because when the compiler reaches to this line, it tries to read alpha. It doesn't get it because it's not a global variable. It's not defined. So it will tell you that this variable is not defined within the scope, right? But here it should work fine because alpha is global for all the functions, so you can use it everywhere, right? So here we have some kind of interesting interactions according to this local and global definition thing. So what we call scope rules, right? So as I said, a variable scope is the block of the code that this variable is defined within it. For example, a local variable to a function, its scope is its function, right? It doesn't have an outside scope. So you can think of the scope is the circle or the lines of codes, that this variable is defined with, right? File scope, which means like global across the whole function in this file. Global variables are having file scope. Function names can be used everywhere if you already had their prototype. Block scope is, as I said, if you define a variable within a function, it's called local variable to this function. But also even further than that, if you define a variable inside a block, assume, for example, I have an if statement that does something, and inside this if, anything within these brackets is a block. So I defined here int x equal 2. In fact, if you try to use x here, it will be undefined. So it will give you an error. Why? Because you defined x within this scope, within this block of code. So it's only known within this block. So you have to pay attention to this as well, right? Then function scope is what the thing that is like visible within the function, right? Okay, so maybe before jumping into this storage duration, it takes a lag to switch. Or am I disconnected? That's interesting because I have two screens. One of them is in a different slide, but yeah. So can you confirm that I'm still connected? Okay, that's interesting. Okay, only the tablet is disconnected. That's okay. So, okay, that's interesting. Okay, let me sure I can just share from here. Okay, I hope you guys are able to see at least the slides, right? Okay, let me see if you are able to see. Okay, good. So yeah, so before jumping into this, this storage duration, we only have 2 minutes left. So I don't want to pass the time, but basically, what if I have two variables with the same name? One is local and one is global. And that's something that is very confusing in programming, right? So if you have this kind of mistake, which you shouldn't do, but in fact, the compiler will not complain, usually the local variable has higher priority. So for example, I defined a global variable called int x. And then inside the main, I also defined int x. That's possible. Inside the main, the value of X that will be used is the local one. Outside the main, the global one will be used. Good? Hopefully I'm still here. Okay. So the last thing is the storage duration of a variable. So whenever the block of code is still valid for the compiler, then the variable is still defined. We said in my main square example in previous slides is that X, Y, and Z, which were within this function, once you left the function, once the compiler called the function, executed the code, and then returned the Z value, X and Y and Z are destroyed. So that means those variables will exist in the memory only as far as their function is being used. Otherwise, they will be destroyed. And this is a benefit of having local variables, is they don't occupy the memory if they are not used. Good. Okay. So the last thing is that assume I want intentionally to have a variable that stays in the memory for the full long duration of the program execution. Now I need to define this as static. So maybe I will come with the example in the beginning of next lecture because it's important to understand. But for now, the thing we will conclude with is static. Oh, I'm gonna try it here. Okay, so static is the word that tells the compiler that this variable will exist in the memory, don't destroy it, even if the function call has ended. So it stays in the memory without destroying it. What is the benefit of this? Next time we will see an example how this can be useful. So now we are done with the content, so you guys are free to leave if you wish. I will look into the questions and then spend a few minutes addressing them. Thank you so much. Okay, let's look into the questions from the end to the beginning. Stop sharing here. And then chat. Okay, would we ever, yeah, thanks everyone. So would we ever define functions in the header file and keep the main in its own file, or is the .h file only for function prototypes? Yes, don't write the implementation of the function in the header file. Write the implementation of the function in a .c file. But this is Muaz's question. So the actual implementation of the function doesn't have to be in the main file. It can be even in another .c file. Like as we have seen in the math example, we had my math.c, we had my math.h, and we had the main file, you can call it my program.c. And my program.c and my math.c are completely two different source files, right? Do we lose marks or get penalized if we finish lab in one git push sitting? Okay, so in lab 0 you will not, because it's a small lab. You can really get the environment in 1 hour or 2 hours, but it's very hard to convince me that a lab with 10 questions that might take you 10 hours of development, you sit for the first time, you do the lab, get it correctly, push, everything is fine. Right? This is very hard to get in. Are you getting penalized? No. But as we said, we do two things. The first one is we have this software tool for checking across the Git repositories all to see if there is any sufficient sufficient evidence for plagiarism, basically. And the second thing is, if issue arises, we will start looking into the commit history, right? So this will not be used against you unless there is another evidence. Right? I really wish we don't reach to this stage. All the purpose here is you guys like learning programming and take my advice. I have taught this course last time. Two problems encounter students that try to get around the actual implementation of the lab. The first one is they did very terrible midterm and final, because I'm assuming you have done the labs, and this is how I put the midterm and the final. So if you didn't do it, this is not You didn't do the exercise you need for the exam. Anyway, this is the first one. The second one is 2SH4 is a fundamental course that 2SI will be built on, and other like embedded systems, like if you are in EE or CE, the whole program is based on that. And not only that, even if you are not in ECE, programming right now is a fundamental skill that you need for any internship. So a sincere advice, regardless of the lab, I'm the last one in the world that cares about grades or marks. You will get your grades and marks in a good way, but the main purpose of doing that is you guys learn, right? So let's focus on that purpose rather than focusing on all these kind of side problems that we don't need. Good. Okay, copy it from the above. So the source file is for making all functions. Then the header is listing them so you can include them in the main. You can look into this like in this way. Yes. Question. So do we have to call the a.h file and the .c file with the functions definition in the no, you only need to call the .h. Go back to my math example we had in the slides. We only used my math.h in our main. Do we have to include the type of the input parameters in the source when you already define them in the header file? Yes, like when you, remember we said the prototype has to match exactly the first line of the function implementation, right? So for example, my main square is taking int x, int y. When you go to the actual implementation of the function, you have to still write int x, int y. You cannot just write x and y. Would we ever define function in the header and keep them? I already addressed that. Okay. Is there a help function in C as there is Python which lists some of the built-in functions? There are some documentation that you can look it up. Like this is Marissa question. So you can look it up easily and Google it, or even look into the C. There are C documentation that lists all the possible functions. When we include the header file to our source code, will it go and find the source files? Yes, if they are in the same Saganan, this is your question. Yes, if they are in the same folder, then you wouldn't have to care about that. The compiler will go ahead and find them for you. The type of the input parameters in the source. Ariana addressed this already. Thomas, why do we not define functions before the main? You can if you wish, but that's not a scalable way of doing things. If you have 100 functions, it's not going to be readable if you include all of them in before the main, right? Okay, so let me see if there are other questions that came late. If a local variable shares the same name with a global name, if the local one is modified, the global one won't be, if the local one is modified, the global one will not be affected. That's, yeah, Alan, that's exactly correct. But if the local one is modified within the scope of the local one, yes, the global one is affected. These are two separate places in memory. But it's very dangerous and very hard to keep track of, as you can imagine, to have two variables with the same name. One is global and one is local, right? So we recommend against that. When lab one will be posted, it's already posted on Avenue, Nicole. It's already out there in Avenue Labs folder, and it starts next Monday. Deadline is October 2nd. Let me see. How does the main function file know where the other function definitions are? Moaz, you include the header file by include.h of all the other function prototypes, and if the source is in the same folder, then the compiler will find it for you. Moaz, so as long as the function definitions are in the same folder, the compiler will find them, yes. If on GitHub it gives me a check mark, does that mean my code is correct, Muhammad? Yes, that means you passed the tests. Does it mean your code is 100% correct? Not necessarily, but you passed the tests we give you. But those tests, as I said before, they are not comprehensive. We have our own internal tests that stress more your code. I mean, lab 0 is very simple, just adding like a single line of code, so it's not a problem. But I'm talking about coming labs, right? So you need to make sure that your implementation is correct, and you are advised to add as many test cases as you can to make sure it's correct. So we give you only samples of test cases, but you can add your own, and we have our internal ones as well. Arjun, can you modify global variables locally, or does this require the global variable to be passed by reference? Yes. If you don't have a local variable with the same name, then yes, you can modify the global variables from anywhere in the code. You don't need to pass it because it's already visible there, right? Where are the check marks, Nicole? So if you look into your GitHub page, like the GitHub web page itself, it tells you what is the commit history, and it tells you whether you pass your the tests or not by the auto grader. But those tests are the ones that exactly you run from Eclipse, right? So if you pass them in Eclipse, you should pass them in Git as well. Question, Wiki. Does main use local variable or global variable of the same name? No. If you define something as global, then it will be also global in main. But I guess maybe your question is, if you define a variable inside the main, is it global or local? It's just local to the main, right? You cannot use it outside the main. In the second last slide, why definition of a static variable can be executed multiple times if it exists all the time? I will explain in detail static variables in the beginning of coming lecture, Gutong. So don't worry about this. I didn't go through the example, so I will do it next time. Okay, are there any other remaining questions? For those who are still having problems with the lab, please drop in the office hours, and hopefully before Friday you get the help you need to get the environment set up. Thanks everyone, and see you on Friday then. Should the test check for errors? They only check for, I mean, what you mean error? Like compiler's errors, Muhammad? Like compiler errors, well, Eclipse will give you that. They only check for correctness as a functionality, right? So yes, if the code has a problem, they should expose it. Okay, thanks. Yes, Arjun, you don't need to attend your, okay, so two things. Don't attend another lab session than yours, because now you're taking the right of someone else. But you don't need to go to your lab session if you are done with the lab. So lab sessions are only for help. That's correct. Thanks, everyone.